Okay, hello. So we'll be continuing on with the properties of quadrilaterals. All right. So quadrilaterals we had established in the previous live, and please, guys, if you're wondering, like, why are we here? When did we start this? In previous live that I did, I actually covered the properties of quadrilaterals. So the video that basically has every other content related to this, you can find all other content on my YouTube link. It's in the bio, and you can check it out and see what other geometry related things we have done so far. So we looked at the square last time, all right? And there's a nice shape there. But what did we learn about it? We learned that both pairs of opposite sides of a square are parallel. Okay. Then we learned that all sides of a square are equal in length. We then learned that all angles are 90 degrees. All angles of a square are 90 respectively. 4. The diagonals bisect at right angles. So the diagonals actually bisect. Okay, and you can see this is equal to that, meaning from here to here it's equal, from here to here it's equal, and from there to there it's equal. Just in the same vein, from here to there it's equal. So the diagonals of a square, they bisect at 90 degrees, and that's very important to note. So here where they actually meet, they make angles of 90 degrees. All right. So the diagonals bisect. Also, they bisect the corner angles. Diagonals bisect the corner angles. In other words, these diagonals, they not only cut each other into half, but they also cut the corner angle, which is 90 degrees, into half. So if they cut the corner angle, which is 90 degrees, into half, it means this angle here is 45 degrees and that angle there is 45 degrees. That's what it means when they say the diagonals bisect the corner angles. All right, and it does so all around the square. Then also we know that the diagonals are equal in length. So the diagonals of a square are very much equal in length. So if you were to measure this diagonal and that diagonal, they would be equal in length, and that's very important to note as well about the square. Okay, so those are 6 important properties of a square, and one who wants to be good and effective in being able to do geometry, you need to be able to know the properties of a square, and that applies for all grades, though this lesson applies to the introductory grades of high school level. Okay, right, let's look at a rectangle, which is kind of close to a square but very different, and I'll show you how. So a rectangle has both pairs of opposite sides parallel. Okay, so just like the square has both pairs of opposite sides parallel, the rectangle also has both pairs of opposite sides parallel. 2, it has both pairs of opposite sides equal. So this side, right, is this pair of sides are equal, and this pair of sides are equal. That's why I've put these symbols. All right, equal in the same way, equal in the same way. So both pairs of opposite sides are equal. All angles respectively are 90 degrees, which means that's 90, that's 90, that's 90, and that's 90. All right. 4, the diagonals bisect each other. So in the same way, the rectangle also has diagonals, but they bisect each other. They don't do so at 90 degrees. They don't, but they cut each other into half. All right, so from here to here will be the same distance, from here to there, and from the same distance from here to there will be the same distance from here to there. All right, so that's very important. So that means this triangle here, these two will be congruent to each other. All right, same isosceles triangle, and this triangle will be congruent to this one. And by congruent, remember that when we say congruent, it means that these triangles, both of them, are very much equal in side and in angle. And this one will be equal in side and in angle. So all the diagonals bisect each other. Then lastly, the diagonals are equal in length. A rectangle has diagonals that are equal in length. So this diagonal is equal to that one. And that's very important. So those are how many properties? 1, 2, 3, 4, 5 fundamental properties of a rectangle. Okay, so it's very important to know these properties. Okay. 2, we'll look at the parallelogram. A parallelogram, I usually call a parallelogram a lazy rectangle. You can see the rectangle is up straight, but a parallelogram is sort of like lazy, you know. So I call it a lazy rectangle. So a parallelogram, 1, has both pairs of opposite sides parallel. Okay, both pairs. So this side is parallel to this one, this side is parallel to that one. Secondly, both pairs of opposite sides are equal. In other words, this side is equal to that one, that side is equal to that one. Thirdly, the diagonals bisect each other. So this diagonal bisects that diagonal. In other words, this diagonal cuts this one into equal halves. So this here will be equal to that, and that here will be equal to that. But please take note, this diagonal cuts this one into half as well, but differently so. So that will be equal to that. All right, and that's very important to note, because you might think that, okay, the distance from here to there, yes, is the same distance from here to there, but it does not mean that this distance from here to there is the same as from that to that. No, it doesn't at all. That only applies for a square, because the square has equal diagonals. So the distance from here to there is the same distance from here to there, which is the same distance from here to there, and the distance from there to there. And a rectangle as well has the same phenomena. The distance from here to there will be the same distance from here to there, which will be the same distance from here to there, and the same distance from there to there. That's why you see 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3, because these are all equal in the same way. In a square, same thing. 1, 2, 1, 2, 1, 2, 1, 2. They are equal in the same way. But for a parallelogram, all right, this is 1, 2, 3, 1, 2, 3, meaning the distance from here to there and from there to there is equal, but it's different for the distance from here to there, because it's 1, 2, 3, 4, 1, 2, 3, 4. All right, because fundamentally these diagonals are not of the same length for a parallelogram. Okay, the diagonals are not of the same length. So I'm just going to recap again. I said 1, that both pairs of opposite sides are parallel for a parallelogram. So this side is parallel to that one, and that side is parallel to that one. 2, both pairs of opposite sides are equal. Definitely, this side is equal to that one, that side is equal to that one. 3, diagonals bisect each other. The word bisect means the diagonals cut each other into half. All right. Yeah, but let's not understand this to mean that this is equal to that and it's also equal to that in the same way. No, it's only from here to there it's equal, from here to there it's equal. So these two are equal, but the equality of these two is different from the equality of those two. Does that make sense? So I hope that's clear for us. And then lastly, the opposite angles of a parallelogram are equal. So this angle is equal to that angle, okay, in a different way that this angle is equal to that one, okay, and that's important for us to note. Then thirdly, the rhombus. Okay, the rhombus. What is it about the rhombus that makes it unique? So a rhombus has both pairs of opposite sides parallel. Okay, that's the first thing. So this side is parallel to that one, that side is parallel to that one. Okay. 2, all sides of a rhombus are equal in length. So 1, 2, 3, 4, all sides are equal in length. We usually even say that the adjacent sides are equal in length. So this side is equal to that one. And obviously if you say the adjacent sides are equal in length, it just means all the sides that are next to each other are equal in length. Does that make sense? So the adjacent sides are equal in length. Or we could say all sides are equal in length. If you say the adjacent sides, a pair of adjacent sides is equal, then you are saying the same thing as all sides are equal in length. You just articulating it in a different way, but it means the very same thing. Okay. Then diagonals bisect at right angles. So I'm going to do, I'll do that after the lesson. What I'll do is I'll post the notes in the on my actual homepage if you want, and then you can look at them from there. Okay. It's just that I might not have sufficient time to allow you guys to write everything, because I want to move on to the kite and to the trapezium, and I have nothing as notes so far, but I'll definitely do that. Okay. All right, so diagonals bisected right angles, okay, sorry, we didn't say that. All sides are equal in length is what we were saying initially about the rhombus. Then here's the other thing: diagonals bisect at right angles. So the diagonals of a rhombus, they bisect. That's the first thing. So that means from here to there, the distance is the same as from here to there. But the distance from here to there is the same as the distance from here to there. But the way that they are the same is different. So from here to there is the same. Same distance from here to there, and from here to there. Same distance. But please understand that from here to there, okay, it's the same distance as from here to there, but it's different from the distance from here to there and from there to here. Okay, so that's why you have different symbols. 1, 2, 1, 2, they are equal, but you have this symbol here and this symbol here to show that these are equal in a different way from these two being equal. All right, so if this, for instance, was 3 centimeters, that would also be 3. But please understand, if this can't also be 3 and 3. It will be 4 and 4. Does that make sense? So these diagonals are actually not equal in length, all in all. All right. So your parallelogram and your rhombus don't have equal diagonals. They don't have equal diagonals. But your square and your rectangle, they have equal diagonals. You see? So that's very important, and it's very important for us to know all those things. Okay. Then also, the diagonals, they don't only bisect, but they make angles of 90 degrees. So there's an angle of 90 here, an angle of 90 here, an angle of 90 there, an angle of 90 there. All right. So they bisect at right angles. That's very important as well. Then lastly, both pairs of diagonals bisect the corner angles. So the diagonal also cuts the corner angle, so that you have the angle here and the angle there being equal. The angle here and the angle there are equal. All right. This diagonal will also cut this corner angle, so that this angle is equal to this one. This angle is equal to that one. But please understand that the way that these two are equal and these two are equal is the same, but the way that these two are equal and these two are equal and these two are equal are the same in a different way that these two are equal. All right, so that's very important as well. All right, yeah, okay. And then both pairs of opposite angles are equal. Okay, so this angle is equal to that one, and that entire angle is equal to that one. So the way that these two are equal is different from the way these two are equal, right? And that's why I've actually written different symbols. I've actually shaded, they are equal, shaded, they are equal, but I've opened to show that these two being equal is different from the way that these ones are equal. So that's very important as well to note. Okay, so these properties, guys, very, very important. They are, if you are in high school and these properties are just not known, I don't know. I don't know. You have to know these properties. You have to actually, like, they have to be posted up on your wall somewhere. You know, you must take down Beyonce, take down Umlindo, take down Scott Mapuma, take down all these prominent people that you have on your wall and start. If you are serious about academic performance and improving your marks in term 3, you know, then you need to make sure that you have these properties up there. All right, and I'm speaking specifically to those who are in the GET phase. If you are in the GET phase, all right, this is relevant to you. These properties are important for you to know. But also, even if you are in FET phase, you have to make sure that these properties are pretty much solidified, so that in geometry, whenever you do geometry, these properties, you can apply them in certain problems that have to do with geometric means. All right, so I hope that's clear for all of us. Now let's move on. We are going to look at a kite. Now a kite is what you see here, and as I write down the property, I am going to come here and I'm going to actually make sure that I mark off the property that I mean. Okay, all right, let me just let me do this for you. Let me just remove my comments, then I'll allow you to screenshot. I will post this on my page, you know, just so you know, because maybe the screenshot might not be as clear, but here you go. Hope you can see that. I'll give you 30 seconds. 30, 29, 28, 27, 26, 25, 24, 23, 22, 21, 20, 19, 18, 17, 16, 15, 14, 13, 12, 11, 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. Okay, we're good. Comments back. Life can proceed. Okay, kite. So a kite has 2 pairs, okay, of adjacent. And there's that word again, the word adjacent. Okay, just a fancy word that means next to each other. All right. Yeah, whenever you are seated in your desk and you are seated in one of those 2-part desks at school, just know that the person seated next to you is adjacent to you. Next to you. That's what the word adjacent means. So 2 pairs of adjacent sides are equal for a what? For a kite. What do we mean by that? You, my guy, you are equal to you, my guy. Then you, my dude, are equal to you, my dude. This side is next to this one. That's what we mean by adjacent. So you, my guy, are equal to you, my guy. You, my dude, are equal to you, my dude. That's what we mean by 2 pairs of adjacent sides equal. All right, in length. If you want to extend it even further. Okay, can I move on to the next property? Property number 2. The longest diagonal bisects the shorter diagonal. The longest diagonal bisects the shorter diagonal. The longer diagonal bisects the shorter diagonal perpendicular. In a perpendicular fashion. Long diagonal bisects short diagonal in a perpendicular fashion. Now, what does this word perpendicular mean? It means that the long diagonal, you can see this is the long diagonal. What does it do? bisects. So that means 1, 2, 3, 1, 2, 3. From here to there is equal to from here to there. Long bisects short. Not short bisects long. No, no, no. Long one bisects the short one. Alright? And it says they bisect such that they are perpendicular. What does that mean? It means that's 90 degrees. Alright? Yeah, so that means we have actually 90 all the way around, if that makes any sense. We have 90 here degrees, that's 90 degrees, that's 90 degrees, that's 90 degrees, and all around that point, those 90s, when we add them up, they give us a beautiful 360 degrees. So diagonals, the long diagonal bisects the short. All right? Hope that is clear for everyone. Okay. 3. The longest diagonal bisects the angles. So the longest diagonal also does what? It bisects the angle. So in other words, guys, this is what this means. It means this angle will be equal to that one, because this diagonal, whatever the angle is here, the entire angle is, it will cut that angle into 2 equal angles. All right? Also this side, this angle will be equal to that angle. But please, I'm sure you can see, because of the symbol that I've put, it means that it doesn't mean that that angle and that angle are equal. No, 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 not at all. Because you can see the star, and the star indicates that this angle and that angle obviously will be equal, but it will be equal in a different way from this angle and that angle. Okay? Please, please, please don't think that, oh, the opposite angles of a kite are equal. No, nonsense. Right? Like I said, the long diagonal, what does it do? It bisects. In other words, it cuts into equal angles the angle at the corner. It's only the long one that does that. The long one is the only one that participates in cutting into 2 equal angles. Then 4. There's one pair of opposite angles that are equal. What? One pair of what? Of opposite angles that are equal. One pair. Now maybe you are asking yourself, what is that one pair of opposite angles that are equal? Well, this angle and that angle are equal. Okay? Very much so. Alright? And you know what? That angle will definitely be equal to that angle in the same way. Right? And that one and that one will also be equal in the same way. That angle and that angle will be equal in the same way, and that angle and that angle will be equal in the same way. So we say one pair of opposite angles are equal. In other words, this entire angle and this entire angle will be equal in angle. Close the door. Okay, so that's very important to note then. Okay, that is our kite done. Then lastly, we have Mr. Trapezium. Mr. Trapezium has one fundamental property, and that is one pair of what? Of opposite sides. One pair of opposite sides are what, guys? You tell me about the trapezium. One pair of opposite sides, they are what? What do we know about the property of Mr. Trapezium? One pair of opposite sides are Let's see if you guys know. One pair of opposite sides are... I'm waiting for someone to tell me. One pair of opposite sides of a trapezium are... I think we have listeners here only. We don't have participators. I'm looking for participators. Where are the participators? One pair of opposite sides of a trapezium are one pair, just one pair. They are what? Thank you, Lesego. Yes, they are parallel. That's what I was waiting for. Thank you. So this symbol stands for parallel lines. And guys, we know that parallel lines, they never meet, you know? They never meet. Parallel lines don't date. Parallel lines don't date. They don't meet up. They don't meet up, guys. They don't meet up. So if I zoom out, guys, those are all the properties of my quadrilaterals, you know. So I usually say to learners that when you think about properties of all these quadrilaterals, you need to look at the word SAD. What does that mean? You need to speak about the property in terms of its sides. What can you tell me about this particular shape's sides, right? That's what the S stands for. So for instance, when I look at the square, you know, what are the things that relate to the sides that I need to know about the square? So here are the things that I need to know. I need to know that both pairs of opposite sides are parallel for a square. 1. 2, I need to know that all sides of a square are equal in length. So that's everything that I need to know about a square as it relates to its what? To its sides. Okay? Then A, what does A stand for? A stands for angles. What do we know about the square's angles? Right? Now here are the things that we know about the square's angles. We know that all angles are 90 degrees. Okay? All angles are 90 degrees. Okay? Yeah, that's what we know about the square and its individual angles. We also know something else. What do we know, D, about its diagonals? Remember, the diagonals are these lines. These lines that basically come from one end of a vertex to the opposite vertex. Okay, where two lines meet, we call this a vertex. The point where the two lines meet, we call it a vertex, and a vertex will form an angle. Okay, so a diagonal is basically a line that extends from one end of a vertex of a shape to another. That's what a diagonal is. Okay, so what do we know then about its diagonals? Okay, and therefore we need to have an idea. Oh, the diagonals bisect at right angles. Okay, we also need to know that the diagonals bisect the corner angles. Okay, so diagonals bisect at right angles. That's the first thing. The diagonals bisect the corner angles, right? And that's very important. Then 6, the diagonals are equal in length. Diagonals are what? Are equal in length. There's an equality in the diagonals. The diagonals bisect at right angles, yes, because angles of 90 will be made here, all right? But when you say they bisect, what does that mean? It also means that this here is equal to that there, that distance from here to there, to the midpoint, or to the middle. The distance from the corner to the middle is the same as the distance from the middle to that other corner. But it's also the same as the distance from this middle to that corner, from this middle to that corner, because all these are equal, because the diagonals are actually what? Equal in length. So if you can unpack what SAD said, hey, when you're feeling very sad, eh? So the next time you feel sad, please guys, don't be sad for too long. Think of, okay, let's go and unpack what the quadrilaterals are actually what properties they possess according to their sides, S, angles, A, D, diagonals. Okay, and if you can do that comfortably with all of these four shapes, then I'm telling you, you will never go wrong with quadrilaterals. You will have quadrilaterals intact for now and forevermore, and this is just a mechanism to be able to remember. I see someone called Britannica saying in the comment section, I'm from Zambia, can you tutor me? I can pay. You can actually just send me a message. You can send me a message privately and we can chat after I'm done with the live session if you want something of that nature in your life, you know. Yeah, but I mean, when I go live, this is for free. No one has to pay anything unless they're feeling generous and they want to gift as just a sense of appreciation on the live. Then I mean, that's also sweet. But yeah, all right, guys, those are our properties, finished and done. Finished and done. Can you imagine? We are finished and done with the properties. Now I think it's time for us to look at some problems that will help us be able to now see if we actually understand our properties and we understand them well. So let's look at number 1, and we are going to here identify the what? The quadrilateral. Okay, and determine the variables. And determine the variables. So just as an introduction, we are just going to see if we can actually identify the given quadrilaterals in this particular situation. And then just a second as I draw these, but I just want to bring our attention to something else. All right, I think I'm having a hard time finding this thing, so it's fine. I'm just gonna proceed. Let us proceed. Okay. Okay. Yes, guys, the thing is I was looking for something, that's why you couldn't see. was looking for something. Alright, and I failed dismally finding it. But it's alright, it's okay. Okay. Alright, here we are, guys. Can we, in the comment section, identify what shape this is? Okay. What shape is this? From what you guys have learned about the properties, what shape, based on the properties you're seeing? Because you see, we have a 90 degrees here, okay, and then we have these two symbols. All right, so what does that to you say is the shape? All right, okay. All right, it seems like in the comment section I'm looking at Gana M1 saying it's a square. Lesejo is also saying it's a square, and then yeah, D is also saying it's a square. And you guys are 100% correct in saying that it is a square. Very proud. Okay, nice, nicely done. Let's look at this one. Right, please forgive me my free-handedness. What shape is this one? Ghana M1 is saying it's a parallelogram. Lesejo is saying it's a trapezium. Gan M1 is saying it's a rhombus. Changing his answer very quickly from a parallelogram to rhombus. Lesejo staying steadfast in saying it's a trapezium. What does everybody else have to say? Okay, I'm sure these are not the only people that are in the live. I can see there's 70 people that are here, but it seems like only a few are responding. I think it goes back to the saying, many are called to do maths, but it seems like a few are chosen to actually respond in a classroom. So, or at least a few decide to respond in a classroom. And that's sad, guys. You know, that's definitely not a way to get ahead. If you're not participative in a classroom, and this is like a classroom setup, if you're not participating, you're not giving contribution, you're not saying anything, you're just watching from the sidelines, but you are intending, you know, in this particular grade that you're in, to do well. It's a problem. Ngoni Princess, yes, we have to sensitize the people so that they actually, it's like the one of the biblical mathematical phrases, if you want, many are called to do maths, but few are chosen. Why? Because they don't participate, they're not active, they're not proactive. Yeah, and then they wonder why the maths is not matching. Okay, so guys, this here, it can't be any other. It's a trapezium. Why do we say it's a trapezium? Do you remember the properties of a trapezium? We said it's one pair of opposite sides are parallel. So this fits the description. What do we see that makes us know that this is a trapezium? It's because we are seeing this symbol, which stands for parallel lines. Please, this symbol here is a symbol that stands for parallel lines. Why did we say this is a square? Remember that here we have a diagonal, and this diagonal here, which is present, has the angle at the corner, which is 90 degrees. Angle at the corner is 90 degrees, and this one is 90. And I mean, guys, of course, if that is 90 and that is 90, that goes without saying that definitely, if these two sides are equal, then of course, most definitely, the adjacent sides are equal, a pair of adjacent sides are equal, that means that pair is also equal, right? And this is 90, so that's why we say that is a square. It fits the properties. Okay. Now we have to have that geometrical eye to see these things. If we don't, problems. We're gonna have serious problems. Let's look at this one. Okay, which shape is this one? Ghana M1 says parallelogram. What does everybody else have to say? Yeah, you can see, like I said, it goes back to my statement earlier on. Many are called. You can see even the numbers in the people is declining. So who lasts? Who endures the test of time? So what is this shape, guys? Okay, so we can see the shape itself, right? There's this symbols. This side is parallel to that one. That side is parallel to that one. Okay, and we are given an angle that's 50 degrees, and we are not given anything else. So obviously we can be safe in saying, all right, because we haven't been told anything else about the sides. The only thing we've been told is that both the pairs, as we can see from the symbols, both pairs of opposite sides are parallel. So that means that this is a what, guys? It's a parallelogram. Okay, it's a parallelogram. Okay, let's go to 1.4. Who are you? Based on your properties, who are you? Who am I? Based on my properties, who am I? JM says, it's just based on the properties that you see. Okay, now I can see many people saying, okay, JM says palm. Okay, I can never say the names of these people that have dots. D0512 says rhombus. JM says kite. Ghana says rhombus. My good beloved friend Lesero says kite. JM says diagonal. Eli says dimensional. Wow. I think it's the first time I'm hearing about that. Dimensional. Right? Yeah. So here, guys, hopefully we can see, there's the long diagonal. This is the short one. Okay? And the opposite angles here are equal. All right? So if you remember from this shape, we learned that the longest diagonal in a perpendicular fashion bisects the shorter one, and we also know that there's one pair of opposite angles that are equal. You can see that pair of opposite angles that are equal, and the fact that the long makes a perpendicular with the short one. So this is a kite. Goes without saying. kite. Okay. Right. I'm going to return and actually add on some things on those diagrams so that we can get some questions based on it. Okay. I will return very shortly. Who are you? Please forgive my imperfect because I'm drawing freehand. Drawing freehand here. And one hand is holding onto a device. So the diagrams may not be necessarily drawn to scale. And that's very important for you to know. Even in exams, diagrams are not necessarily drawn to scale. What shape is this? You tell me. What quadrilateral shape is this? Okay, guys, I'm gonna end the live at 9:30 because I need to go. So in 20 minutes, I'll be ending the live, right? And then we'll continue at another time. Yeah, be very careful. You can see most this shape. There's something about it. Right? JM, be careful. I see what you've said, JM, in the comment section. All right. Lesejo says it's a rhombus. It's your boy, Sneyman. It's your boy, Sneyman. Sneyman. Yes, yes, yes. Guys, both pairs opposite sides are parallel, as you can see. Okay. Parallel. Remember, parallel lines are lines that never meet. Okay. They never meet. They never date. Parallel, you know, yeah. We are in grade 9, the both of us. We are heading from grade 9 to 12. We are moving in the same direction, but we are never meeting as boy and girl to have some sort of whatever. The parallel lines never meet. When lines are parallel, they just are lines that never meet. They never touch. If they are parallel, it does not mean they are equal. It just means they are parallel. Okay, that's why, for instance, a trapezium, right? Because I think sometimes learners think parallel means equal. This line is parallel to that one. But that does not mean or imply that this side is equal to that. No, no, no. It just means that these lines, they never what? They never meet. Okay? But additionally, on top of both pairs of opposite sides being parallel, what else are we told? We are told this side is equal to that one. That implies that the adjacent sides are equal. If the adjacent sides are equal here, it would obviously imply that those same adjacent sides would be equal in the same way here and there. So what type of shape is this? Ki what? Ki rhombus. Ki rhombus. 1.6. I'm sure people are already guessing before I even finish drawing this one. Look at how fast you guys were in guessing what this one is. Okay, so this one, it's clean. It's a what? It's a rectangle. You guys get that one. Okay, I'll give you that one. See, it seems like people are very confident about Mr. Rectangle. No questions asked, no doubts about it. It's like we know what we know, and we know it, and no one can tell us anything. Okay. All right. So guys, please, whenever we want to identify the kinds of shapes, let us be very much aware of the properties that apply to those shapes so that it can be smooth. Our identification can be smooth. And when our identification is smooth, then we'll be fine. You see? I'm brilliant. What are you talking about? Square rectangle. Sis. What nonsense is that? Gee, this guy. Oh, Messier. Tando Lwetu, you're not brilliant after all. You're writing funky stuff here. Square, rectangle. So when you are merging, you are magifying the two. No. Please, let's stick to just the distinction, right? I get the fact that you are saying what you are saying based on the 90 degrees, but let that not be a basis to say such, right? So, all right. Now, I want to step just a little bit and add variables here as we conclude today's session. Now, if I was to say, what is the value of x? Okay. What would you say? Okay, and what's your reason? I agree. What's your reason? I need a reason. You can't just tell me x is 45 degrees. I need a reason. What is the reason? I agree. X is 45 degrees. But I need a reason that is 100% correct. Okay. So now I take you back to the document. I told you guys that you need to be 100% with, right? Yeah. So I love what you guys are saying. I love it so much. At the comment section, Rorisang said bisect each other, but no, it's not about the bisecting each other. Ghana M1 says diagonals bisect. Okay? Yeah, but you're not being specific. All right. Elihle says diagonals bisect corner angles equally. Now, I would give Elihle M the marks. All right. Okay. Other reasons that have been stated above don't fully capture the full reason why we are saying x is 45 degrees, but Elihle M's response fully captures why we are saying x is 45 degrees. It's because we know that the diagonal of a rhombus, of a square, bisects what? It bisects the corner angles. Diagonals bisect the corner angles. Now, I want to say that there's that document that I told you about called the acceptable reason document. That document has the shortened reasons that we can write that even your teacher will accept. It doesn't care what the textbook says. The textbook may say something, but your teacher will have to accept this reason if you write it because it's in that document. Okay, the one that I'm going to write right now. So if you said diags of rhombus, I'm saying diags of rhombus, diags of square, then you would be 100% correct. Okay. Now, diags is just the short for diagonals, and then you say of square. Now, anything that has to do with the diagonal of a square that you know will apply as the reason if ever you want to say something about the diagonals of a square. Whether the diagonals of a square, they bisect corner angles, or the diagonals of a square, they bisect each other at 90 degrees, you are safe when you say diags of square. Full stop. So, diags of square is a summarized reason that caters for all things that have to do with diagonals. Whether you are saying diagonals are equal in length, that being the reason of you saying maybe a certain midpoint to a corner is a certain length, or whether you say diagonals bisect the corner angles, or whether you say diagonals bisect at right angles. When you say diags of square, that caters for everything. It's a one reason caters for all. when it comes to the diagonals. Remember, I said properties relating to diagonals, the D. If you are now wanting to give a reason for why x is 45 degrees, and yes, you know the fact that the diagonals of a rhombus, they bisect the corner angles, you can just summarize and say diags of square. You will be given all the marks. But your teacher will not give you marks if you write what Elisha wrote down, because that reason is obviously a full reason that basically is even explaining, because you understand why x is 45 degrees. But I want to say to you, if you summarize it and say diags of square, you will get all the marks. You will not be niched the marks. All right. So I hope you guys understand what I've just explained. Okay, guys, because of my commitments that are otherwise, I'm going to end the live here. I know it's short, sweet, straightforward, to the point, but this is what I wanted to do for today. When I pick it up again, I will pick up the lesson from here. I have the feeling that I'll be back here at 1 p.m. Okay, 1 p.m. I'll be back here to do a continuation of this and extend it even further so that we can cover the rest of quadrilaterals and what they have to offer. Because remember, term 3, grade 9, this is what we are doing. And if we can do it well, it will be great. Good night, say. Aye, man, don't be funny here, Elisha. It's not good night. Good morning. What are you talking about? So I'll see you guys at 1 p.m. Today. Cheers. And I'll be saving all of these videos I actually upload onto my YouTube channel. There's already a playlist of the series that I started of the Euclidean geometry for grade 9s and grade 8s. It's relevant for grade 8s and 9s up until a certain point. So please, guys, go and check out the YouTube link. There's a playlist for grade 8 and 9 geometry. You can see what I've done. We've been doing live sessions on geometry, and we are on quadrilaterals now because we are continuing with it. I will finish off quadrilaterals because it's relevant for grade 9s. Then we'll do congruency. We'll do similarity as well, because grade 9s do similarity in geometry as well. So, okay, thank you so much. I hope you have a good one. And I'll see you guys at 1 p.m. during the day.